Hi everyone, my name is Noah. Welcome to another Get Together workshop. Today I'm going to be introducing WebSockets and how you can use that in an online web browser game, which I think many people said that were interested in doing in the forum. So yeah, the skeleton code in the description below is an online version of Tic-Tac-Toe, which uses WebSockets to communicate between the two clients, the two players, and the server in a full duplex manner. So, meaning that throughout the entire game, there is a continuous connection between the two clients and the server, which is something that you can't get with an ordinary HTTP style connection. So, before going forward, I just wanted to give you a quick introduction to the contents of this skeleton code. So we have our game folder. This folder has two files: the events.py file, which has all of the event listeners. So we're going to talk about that in later when we're talking about sockets, but it's based on some event listeners and emitting events. So we have some event listeners in and how the code to handle uh, all the stuff on like the game state and all that in the events.py. The game state itself, the classes for the game, the room, and the room manager are all in the logic.py file. Our app.py, it's a very, very bare bones app, but all of the code is basically in events.py, which references logic.py. We also have our HTML file for our tic-tac-toe, so it's pretty basic. All the files in here are pretty short. And we also have a JavaScript file which runs the code when we click the buttons and also has some event listeners here as well, which we'll get into later. So to run this code, you're going to have to create a virtual environment. So you can do something like Python 3-m venv, and then the name of your environment. And then to activate your environment, you can do source env bin activate, and you'll be in your virtual environment. So then you'd install the requirements in the modules in requirements.txt. So for our app, we mainly just need Flask and Flask-SocketIO, and then run the app with Python 3 app.py. Okay, so this is what our skeleton code does. We have a online version of Tic-Tac-Toe. You notice I can actually, if you are on the same network, you can use your IP address and you can connect with someone on a completely different computer, but just for uh, this demonstration, I'll be on the same computer. I can click aside, join a game. So this is actually a room. If I join on another uh, tab, I'll actually not be in this room, so I can't send updates to this game. That's one of the things that SocketIO does is you can have rooms, and you can see when I make a move, it immediately appears on the other screen, which is super cool. Um, I can make a move here. And yeah, it's just really cool that you can have instantaneous updates sent to the other client, which is something you can't really do with HTTP. You see, if I win, the game state now says, all right, we win. So like I can't make any more moves. I can restart the game. And if I leave this tab, SocketIO will send a disconnect to the other client saying the opponent disconnected. Yeah, so we're going to go through how that all works and how sockets work and how you can put this in your own app. So the main question that we're trying to go over this workshop is how do I connect two apps over a network? So if I have one phone with its own tic-tac-toe process and another phone across the network with its other tic-tac-toe process, how do I make it so that if I make a move as X over here, that it sends a not only an update to the server, but the server also updates all of the clients as well in this room. So if you note in a ordinary HTTP, how HTTP works is that this client would send an HTTP request. It could be a GET, a POST, something to update the server, and the server would send the resources back, saying maybe like with the new game state or something like that, and then it would sever the connection. The HTTP connection ends there. So it's not maintained. It's not like a continuous connection over the entire game. It's only when the client needs some sort of resource. So what about this client? So if this client updates the server and the server updates the client, there's no way for this client to know, hey, I need to update my state as well. So it's only on the client to ask the server for updates. The server can't ask the client for updates. The server can't send stuff to the client without the client asking. So one thing that early people did to counter this was called polling. So when this client is making a move, this client is going to repeatedly ask the server, "Hey, is there any updates on the game state?" Maybe like every second, send a request to the server for the game state. So that could work on something like Tic-Tac-Toe, but it's a big waste of bandwidth, and it's also just laggy. If you're doing like a first-person shooter or something like that, where like the timing of it is super important, then you're gonna have a huge lag on when the client makes a move and when the other client receives it. So how do we combat that? So the way we're going to go about it is through WebSockets. So instead of having like a HTTP connection which just terminates after the resource is given to the client, the WebSocket is a maintained connection. So when someone logs into Tic-Tac-Toe, like as I did earlier in the video, like throughout that entire time I'm connected to that I'm on Tic-Tac-Toe, I will have a socket connection with the server. So that means throughout the time I'm on that website, my client and the server will be connected, and my client will be looking for socket emits from the server. The server will also be looking for socket emits from the client, and yeah, we'll have a persistent connection throughout the game. So that's how I'm able to have the changes in the server immediately reflect in the client, and how I can have a connection go from this client sent to the server, and the server able to send a emit back to another client, and it looks almost instantaneous from when I click the X over here and when it shows up over here, because there's a continuous connection, and the client doesn't have to keep asking the server for resources. So that's the power of WebSockets. And we can use something called SocketIO. So SocketIO is a library that implements sockets, and it does a lot of stuff in the background. So we can create a SocketIO object in the server. So over here at the top of our server, actually it's an app.py. We import the SocketIO object, and then that SocketIO object is going to stay for the remainder of the run time of the server, and it's going to, when someone sends a HTTP request, it's going to establish a socket connection and also maintain the socket IDs, and it's going to put that in this request.sid over here. So whenever we're listening for socket connections, we will also keep track of the socket ID, so we're able to like uniquely identify the different processes. So that's what SocketIO does. We also have a SocketIO object on the client side. So we have a SocketIO object in the server. We also have one in the client, which we import in the HTML. So we actually have a script here that installs the SocketIO object, and then we reference it in the game. So we have two socket objects, and they're both listening for events and emitting events. SocketIO is event-based, so you can imagine we have this pipe. We have our client, which is looking at Tic-Tac-Toe. We have our server, which is actually organizing the game. It has the Tic-Tac-Toe game, like it has the game state loaded in memory. And we have this pipe, which is our socket connection. And how the client and the server communicates is through events. For instance, when the player clicks choose player, so I chose X, the client is going to send an event to the server. It's called join. And then the server in events is going to listen for event join and then run some code which depends on what we want to do. Like when a person joins, we want to check if the room already exists. find a room, and then if there's no room, create a room for them. So it's all event based, and all of these are listeners for events. And we may emit events when we want to communicate between the server and the client. So that's super important. In this pipe, the way that we communicate is through events. So you'll see that throughout the code. So the way to start is to first install Flask and SocketIO. So as we showed earlier, install it with requirements.txt, or you could just make your own environment and do pip install Flask and these packages. In order to first start, you'll notice when reading the code, it's short, but it's really organized. It's hard for you to kind of maybe think like, how do I even start? How do you know to put a room manager, to have the room, to have game state? How do you know that you want to use these event listeners? Because this is just a name. It doesn't have to be join. I just called this event join. And in the client, I just happen to emit join. But if I called it join to, I would have a corresponding listener on the server for join to. So it could be whatever you want to call it, but it just has to match the event that you're sending out from the client and the server. So in planning it, you really want to think like abstract, like first, what are the entities that you're dealing with? So we have two players in a game, so you could even have a class for the player. But just because it's a super simple game, I'm just not going to bother with that. Uh, I'm just going to use the socket ID for the players, and then so they are in the game. The game has a board. It might have some states like, we're waiting for an opponent. Maybe we're in progress. Maybe the game's over and we can save it to some database. We have a room for the corresponding game, which holds the socket IDs. So that's going to be what differentiates our games, and we want our socket connections to stay within the room, not go outside of the room. And that's what Socket.io does, is we actually have a join room function from Socket.io. So if we pass in a string, like our room ID, then when we send our events out, like with this emit, it's only going to send them to the specified room ID. So then if you won't have cases where one game is going to influence another game. So the events are only going to stay within the game. That's also what Socket.io does. Um, and you have some room manager, which is going to uh, organize the room. So we have a list of rooms, we have a dictionary of rooms, and we have functions to create rooms, look for open rooms. If we have a player, we want to find the room ID for that player, and maybe, yeah, something to do if the room is empty and all the players have left. We want to get rid of that room. So we want to think of the classes that we want to deal with. Then we can think about our game states, which might relate to the classes, what we want to store in those classes, like especially game state. And then the most important thing when dealing with sockets is the events. So when you have an event and you emit and you have a listener, you can actually send data with that event. So for example, if we have our make move, it's going to emit a event to the server, and we can pass the grid, like the square in our tic-tac-toe, with that move. So when we send this message to the server, we want to include the position of the grid that we just made our move, so that when our server gets that connection, gets that message, no, for make a move, it is able to make that move, like call the code with the function, with the index that the player put that move in. So for all the events, you also want to think about the data that we're going to pass through. So like for join, we want to think about the side that we're on. So if we're joining a, a game, you can either be X or O. So it's pretty important for the lobby to know, for the server to know whether you're an X or an O for the purposes of like filling up the game. when you're moving, you want to make sure we send the spot that we're moving in. Maybe you also want to include the side that we're on. Depends on how you coded your game state. And then update. So every time a move is made, we want to update that for the other players in the game. So we want to update the board state and maybe some other things about the game. And disconnect, that is like this is actually a SocketIO emit. We don't have a emit on the client side because when I close the tab, SocketIO automatically sends out from that tab a event to the server saying this client just disconnected. So we can have some code for handling when a client disconnects too, which is cool. So this is how you plan it. Before you start coding your events.py or even your event listeners on the client, you're going to want to think about the events and the data that you're working with. And also just to explain like the syntax real quick for the JavaScript, this is going to be the name of your event that you're listening for. This in the curly brackets, this is a function, and this is the output of the function. So this is the parameters. This is called an arrow function, and this is the what the function is going to do. So when you have this update event, this is the data that we're passing in. So we're saying, okay, pass in when we update the board for the other players, we want to give the board whose turn it is, whether or not someone has won, whether or not the game is ready yet, and then we're gonna run all this code in here. So that's just the syntax for the client side. On the server side, we have uh, this like decorator, and it says look out for join, and then when we get this connection, we're gonna run this code. So that's how it works. So that's why it's kind of like instantaneous, is because instead of repeatedly sending HTTP requests, we have a listener that is continuously listening for socket events that we're sending between the client and the server. Another way to visualize this, which is super useful, is with a sequence diagram. Because it's super confusing to kind of go through the code. You might have to go back and forth between game and events over and over again. Um, but you can use a sequence diagram to kind of visualize the flow of your connection, especially if you're dealing with like a bug and you want to find out where in this diagram that bug occurs. So imagine here, P1, we have player one, we have player two. Player one is on localhost, so it already has a socket connection with the server. Player two also has a socket connection with the server, and player one clicks join as X, and then player two clicks join as O, and then player one tries moving when it's not their turn. Player two then moves, the board is updated, and player one disconnects, and the game is stopped. So that's our situation. If we go through the code, imagine player one joins and clicks choose player X. Then we have to jump to game.js and go to choose player, and it updates some stuff on the front end and sends a connection join, an event join to the server. So this is where that arrow is. So now we're on the server. The server has a listener for join. It looks for a room. There's no room because there's no rooms yet. Creates a room, and we call that A, and puts that player in that room. So now we have a room A with just one player X. Um, And yeah, so then now there's the room's not full, so we're just gonna wait and send a emit wait to the browser so our browser can display, hey, we're waiting, so just don't do anything right now. It's gonna show something on the client. So so like you notice like we don't need to do like a HTTP uh, the server doesn't have to send a HTTP like message to the client. We can just do all of this with sockets. And then the player two does join as well. So player two clicks on choose player O. You can follow the code here. Um, choose player, and then sends another socket message join. But notice this is not the same one as player one. It's coming from player two. It's a different socket connection. So now the server also, still listening for join. It's listening for join the entire time. Gets this message. The room is full, so it updates. It sends a connection to all the people in the room. So when we called this join room function from the Flask-SocketIO object, it it puts the two socket IDs for player one and player two into a room so that when we do this emit, this update goes to all the players in this room, which happen to be player one and player two. So when we send this update, we're updating them with the entire game state. So it's player one's turn, but it's not player. It's player two's turn, but it's not player one's turn. So then player one clicks on move. It clicks on like one of these cells, so it makes a move. Goes to this function in JavaScript, which emits move, which is a different event. The server, which is always listening for events, it gets move and it runs this code and it says, "Hey," runs this make move function, which is in logic, and it says, "Hey, wait a minute, like you you can't make a move because it's not your turn." So it returns false, and moved is nothing, so there's no emit here. Like we're not gonna update the screen because making a move is just impossible. So we're not gonna do anything there. So that's this arrow, and then player two runs move. So it clicks one of these cells, runs make move, sends another connection for move, but note like the index may be the same, but in events it's going to be a different socket ID. So when player one clicked move, it's their own socket ID, and this move function said, "Wait a minute, it's not your turn." Player two, when they ran move, has their own socket ID, and this function rightly says, "Hey, it's your turn, so you made your move." And when the move is made, which is all handled in logic.py, that's the game code. Then we're going to be able to send an event update to everyone in our room and update the board accordingly. So note how, it's pretty like it is kind of all over the place. Like the action is made in the HTML by like clicking a button. That calls some code in the JavaScript, which may send an event which is listened to on the server side. So this is our server listeners. It might even send uh, updates back to the client. So we have our corresponding uh, listeners on the client. So this kind of it can get really, really messy, especially when you start having like different versions of update. Like maybe you're playing a different game and you need like a separate, update to listener, and you might go back and forth, and you might get really confused. So it's really useful to use something like a sequence diagram, especially in debugging or planning, to figure out like what exactly is going on, what data is being stored. So I encourage you to go through this code and try to make your own sequence diagrams, or even just go through this one to try to understand what it's doing. Thank you guys for watching. I hope that this skeleton code and maybe this walkthrough on like how sockets works has been worthwhile. Because like the aspects that the skeleton code and that we've touched on in this video, it's definitely going to be used if you're making a game. You're going to be doing very similar things. You're going to be making rooms, you're going to be joining the rooms, and you may have to, you know, update the screen for the players when someone makes a move. So there's a lot of like similar events that you have to look out for when you're making a game, and I think that this Tic-Tac-Toe app it touches on a lot of the very common ones. So especially if you're going to be making a web-based online game, please look at the skeleton code and let me know if you have any questions. Thank you so much for watching, and good luck with your app.